Okay, sorry, someone. No, don't worry about it. So let's continue. So again, correlation is necessary for causation, but causation is not necessary for correlation, as we're going to see. So again, these are kind of our two main research designs, and there's a lot of, you know, variations on them, and sometimes you even do combine them, correlation and experimental stuff. But for now, just remember these two designs. Correlation is when you're measuring two or more variables and you're looking for a relationship among them. So do they go in the same direction? Do they go in opposite direction? Or maybe neither. Um, experimental, remember, is when you actually manipulate something, you manipulate one variable and see does that cause a change in another variable. Here, there's actual evidence of causality. Okay, so let's keep digging into why relational research doesn't really tell us whether there's actual causality. And I apologize if this gets redundant, but it's an extremely important thing to remember and something you should always ask whenever you hear a research claim. So remember with correlational, we're just looking to see do two variables covary. So if one goes up, does the other go up? More smoking, is that associated with a higher probability of lung cancer? Um, the more time you spend studying, is that associated with a higher GPA? Those would be positive correlations. A negative correlation would be as one thing goes up, does the other one typically go down? But again, we're not manipulating those things. We're just looking at existing data. Is there a relationship there? So negative correlation would be, let's say, number of drinks per week and GPA. Maybe if you drink too much, your GPA goes down. So we're going to kind of see as we go through this how these are not really under control, and thus we can't rule out other explanations, and we also can't account for third variables, and we can't establish temporal precedence, two of the key factors in determining causality. Just another note on correlation. So when you make a hypothesis for a correlation, it's just going to be what is the direction. So you can predict that as one thing goes up, the other one typically goes up, or a negative, or predict a negative relationship where one thing goes up, the other is going to go down. So we tend to use correlations whenever whenever it's kind of tough to manipulate a variable or impossible to manipulate a variable. So there's certain things that you kind of have to look at using correlational designs. For example, let's say we looked at self-efficacy and time before you help someone who seems to be in trouble. Well, we can't really manipulate self-efficacy as far as I know. So we need to consider, okay, we're just measuring that and seeing as that goes up, does their time to help maybe go down? Okay. Well, so let's again think about correlational research. So it doesn't fill the two of the three criteria we need to infer causality. First one being temporal precedence, which is key for directionality, and the other one about ruling out other possibilities. We're going to look at examples of both of these. Okay, so the biggest thing often with correlational data is that we can't tell which is the cause and which is the effect. That's one problem. So just like the chicken and the egg problem, for really any correlational data, we don't know what might be causing what, if any. So let's look at a few issues. Let's look at an example in just a second. Actually, yeah, that example now. So the biggest one that always comes to mind is any form of violent media and aggressive tendencies or aggressive behavior. So I don't know if this is true or not, but I know some have argued that more consumption of or more watching of, say, violent TV or playing violent games or violent movies is associated with violent behaviors. So, I mean, that is a testable hypothesis, right? We can look at, we can survey people and ask how many violent games, how many hours do you spend playing violent games per week, and how many times have you been arrested, or how many times have you assaulted another person, or whatever it might be. So it is something we can test, but the problem here is that we, of course, can't infer causality because we don't know if there's temporal precedence or what that might be, and we don't know which variable might be causing a difference in which. So it could go either way, right? For example, do they watch this violent TV first and then do some sort of aggressive behavior? Or it could be the opposite, right? It could be that people who are more aggressive or more violent naturally gravitate toward more violent TV, right? Let that sink in, right? You've probably heard this example before, but someone who maybe is violent, I don't know if there's any truth to this either way, but it's just an example. Someone who likes or behaves violently might be naturally attracted, they might be more interested in seeing violent TV. So someone maybe who, say, gets in a lot of fights might be interested to see movies with a lot of fights in them, right? Or TV shows with a lot of fights in them. Or it could be the other way around, right? It could be that, again, as some people have argued, um, they watch the violent media and then that causes them to behave more violent. But the bottom line is that we don't actually know because we're just measuring these and we don't know which is coming first. And also keep in mind that sometimes you can measure the variables at different times. There are certain studies where that works and that helps for sure. You still run into the third variable problem, but it at least is an improvement. But then there are a lot of things we can't measure because they're constant. They're kind of going on, or we can't establish temporal precedence because they're going on at the same time. So to put that more concretely, it's not the case that someone watches, one violent thing and then we happen to know 2 days later they do something violent, right? At least that would be very rare. But instead, what's actually probably going to happen is that people, you're looking at a long time span. So you're looking at, someone who watches however many violent TV shows per week and over the course of, like, say, a few years and also did X amount of violent behaviors over that 3 years, right? So it's not the case that there's obvious temporal precedence there. We don't know which came first, the aggressive TV or sorry, the violent TV or the aggressive behavior, right? We can't, again, establish temporal precedence there, okay? And you could think of this for, like, probably think of a lot of examples where this might be the case. So anytime you see a study claiming, you know, this food might improve your health, your first question should be, as a good critical thinker, skeptical person, is the data correlational? So let's say you read a study, or rather hear of a study that says drinking red wine might actually be good for you. Take a second and think, what's the problem there? Why is that not, you know, what might be the problem with that finding or that assumption? Well, the problem is that we don't. It's probably correlational. It could be experiment, but let's say it's correlation. Well, we don't really know, you know, what's what's coming first there, right? I mean, if someone is doing pretty well, they're making good money, Actually, let me come back to that example. That's more of the third issue. Bottom line is that a lot of times we can't establish the order of things, and that's again a key assumption for causality. So yeah, forget that other example, but think of this one again. Which came first, the aggressive behavior or the violent TV? We don't know. They kind of happened at the same time. So, you know, tough to say. I'll give you another example. Let's say you find a correlation between depression and video games, right? I don't mean to hate on video games here. I love them myself, but just as an example, because lots of people seem to think this. Say you find a correlation between playing video games and depression. Well, we don't really know, what the temporal order was there. So, like, did they start playing games before they got depressed, or did they get depressed before they started playing games? Maybe if they have no energy or no desire to go out and do things that they used to enjoy, they just play a lot of games all day, or maybe the games made them depressed. Um, as an example, it's kind of tough to tease those two things apart because again, it's correlational. We don't know which came first. Chances are they kind of came about at the same time, so we don't really know. And of course, if you ask someone, "Are you depressed? How many games do you play?" They're not really going to be aware of, when which came first either. So that's the other problem. Okay, so don't forget that. Just another note, just because we have arrows doesn't mean the data isn't correlational. Sometimes they're just used to illustrate certain statistical models, and they don't really tell us that there's actual causation. So, for example, um, there's something known as a mediation model. You don't have to really know what that is, but it's just the idea that kind of if one thing correlates with a second thing and then correlates a third thing, you can kind of use that to argue that that's what's that's what's going on here. So for example, if you have friends that smoke and you from that develop a positive image of smokers, then you might become a person who smokes. That's kind of you can look at the correlations between these variables and say, for example, does friend smoking make you smoke, or is it only that friend smoking gives you a positive image of smokers, which then is associated with you smoking? Um, this is still not causation. This is still correlational research. So don't let the arrows fool you. This this example could still go either way, right? Could be that seeing your friends smoke gives you a positive image of smokers, which then causes you to smoke. But it could be the opposite, other way, right? It could be that you smoke and that causes you to make friends who also smoke, and that kind of both of those things give you a positive image of smokers, right? So just because there's these lines and these mediations doesn't um, there's actual causation. Okay, so that's point number one. So again, we don't know temporal precedence. We're not satisfying that criteria. We don't know the directionality. But what's the other problem with correlations? Well, the other one is that we don't know if there are any third variables involved. So we don't know, it might be the case that two variables correlate because both of them correlate with a third variable. Okay? And don't worry, I'll give you concrete examples in just a minute. For example, we might be looking at a correlation between A and B and think, well, gee, if we weren't well practicing this of G, A must be causing B there. But because we didn't, manipulate either of these things, we don't know if there's some other thing actually, you know, causing the relationship. So rather than A being correlated with B, A, might correlate with C, and B might also correlate with C. That's going to make it look like A is correlated with B when they're not. They're both just correlated with a third variable. So let's see. So what would be some examples of this? Well, One thing I mentioned earlier was ice cream sales and shark attacks, and I think that is a real thing that people have found. So they found that the more ice cream sold, you know, per city or maybe it's per beach, I don't know, is associated with more people getting eaten by sharks. What's the third variable there? Well, probably hot weather, right? If it's hot out, people are going to be buying more ice cream. If it's hot out, they're also going to be um, on the beach, at the beach, or swimming or boating, right? No one goes swimming in cold weather. So it's not the case that ice cream sales actually correlate with shark attacks, but ice cream sales correlate with warm weather, and warm weather correlates with shark attacks because again, people go swimming when it's warm. Okay. Um, you could probably think of lots of examples of this. So another good one might be the one I mentioned earlier of is drinking red wine good for you? Well, if that's a correlational study, then we don't know what third variables might be at play there. So do people who drink red wine, does that actually cause better health? Probably not, right? It's probably the case that people who drink a lot of red wine are, fancy people with good money that are well fed, get a lot of good nutrition. Maybe they're pretty happy with their life and they're not super stressed, and all those things are actually causing better health. And the red wine is just correlated with better overall quality of life or whatever, and that better overall quality of life is actually correlated with better health. So it's not again that red wine correlates with um, better health. It's red wine correlates with other things, and those other things correlate with better health. Right? All right. Now, another thing to note is that it is possible to do something known as a partial correlation, um, or even what's known as a multiple regression. And this is where you basically take out the correlation. You basically take out the third variable and see is there still um, a relationship there. So if I wanted to look at um, ice cream sales and shark attacks, if I were to take out heat, basically just take away the correlation between A and C and C and B, and just like if I cancel that part out, is there still a correlation between A and B? Um, that does help, but that still doesn't really provide strong evidence of causation because we don't know what we don't know, and um, we can't be sure that we covered all those um, third variables, right? So there might be a third variable that we're missing. Okay? I mean, you can't measure everything. There could always be a third variable that you missed, which is kind of the other requirement. We're missing the third requirement here, which is to rule out possible causes. Now, keep that in mind too. Again, helps if you can present a little bit better of a case by saying, look, we controlled for all these other third variables and still found a relationship, but you don't know what you're missing, what you might be missing. So there could still be another variable that you didn't control for that's actually producing the relationship. Um, so bottom line is we can't really rule out other possible causes, and we missed the third criterion. Okay, so we spent some time now kind of dissing correlations and saying the problems associated with them in terms of causality, but um, what are the actual uses of correlation? If we can't determine causality, are they still useful? Yes, they are still certainly useful for a number of reasons. One is the early stages of research. So sometimes it's just kind of easier, practically speaking, to look for a correlation before you go about investigating it experimentally. Um, that's definitely one use of correlation. But the research kind of hits a stop way if you can never really demonstrate it experimentally. I'll give you an example of this. There's been some debate for a while over whether music improves your cognitive skills. So I think it's multitasking or some other things like that. Does actually playing an instrument improve those skills? Well, there's definitely a correlation there. So when you just look at the pre-existing numbers of how long have you played, do you play an instrument, and how good are you? What are your abilities in, say, multitasking, whatever other cognitive skill? There is a correlation there. People who play music tend to be better at those things. But that's just kind of a good starting point. If you wanted to argue more certainly that music, learning an instrument actually improves your cognitive skills, well, then we'd need to go on and test that experimentally. But again, looking at it from a correlational perspective is a good starting point. The other big thing is, when manipulating variables can be practical or unethical. So there's plenty of situations where it's just really not possible to manipulate something, and we kind of have no choice but to rely on a correlation. So for example, let's say something like, say, smoking and lung cancer. You obviously can't manipulate that, at least not with people. So you can't, give them lung cancer from a study. It's not ethical, right? Um, in that situation, or something like, say, child abuse, and looking at later life outcomes, that's obviously not something we can manipulate. It's unethical. So there, you kind of have to just look at correlations between child abuse or smoking and various outcomes. The last one is when you're interested in relating two or more naturally occurring variables. So if it's just not really realistic, or you know you have some other reason that you want to look at things in a naturalistic setting, you sometimes have to go correlation. The last one is that when manipulation is not really, it's possible, but it's not really realistic. It doesn't really capture um, what the actual situation would be like. So just to give you that example again of, say, music, certain cognitive skills. Well, I mean, yes, you could run an experiment there. You could look at, you give someone who never played an instrument before, have them learn it, um, or learn some of it, and then test their cognitive skills. I mean, you could do that, and people have tried, but it's not very realistic in terms of what we actually see in the real world. And this kind of ties in with issue number 3 as well. They kind of overlap here. So presumably with music, any difference, let's just say hypothetically, that does actually cause better cognitive skills. Well, it's probably not going to be some kind of short-term benefit. It's not like you can pick up an instrument and practice it for an hour and that's going to improve whatever cognitive skill we're interested in. Rather, it's going to be years and years of music practice that's going to improve said cognitive skill, right? So with that in mind, it is kind of tough, although possible, it's just really not practical or realistic to manipulate that in the lab. It'd be tough to get people to do practice, a musical instrument for years just for a study. So that's another thing where you might have to go with correlational data where it's just not realistic in terms of what we're studying. To give you another example, let's say you looked at video games and attentional control. So can you basically filter out irrelevant information and focus better if you play a lot of games? There's actually some evidence of that. Well, it's just like with music, it's not really, that's probably something that develops over maybe a lifespan or even at least several years. So years of gaming maybe lets you better control your attention. With that in mind, it's kind of tough to say, okay, um, you know, come into the lab for like an hour and we'll see if that, we'll have you play some games and see if that improves your ability to control your attention, right? It's not really comparable to what we actually want to examine in the real world. So that's kind of another, actually I shouldn't say issue, but reason to use correlational research. Okay. One other area in which correlation is still really useful is just when all you care about is prediction. Um, so there might be cases where you're not actually thinking there is any causation there, and that's fine. So to give you a couple examples, well, actually, one kind of overarching example is any kind of selection process, like deciding if you want to hire someone for a job, if you want to allow them into a university, anything like that. In that situation, prediction can be very useful and is utilized quite a lot. So take, for example, um, college admissions, right? So if you're going, if a college is trying to decide whether they want to admit you or not, they have to kind of look at all the applicants because they can't take them all, or at least some of the time they can't. Um, and they have to decide, okay, who of these students are we going to admit? Well, I mean, they can't just do that based on intuition because that's not really going to tell them. That wouldn't be helpful at all. So they need to kind of establish some criteria as to what's actually going to predict college success. So of the students we accept, which ones are most likely to graduate, which ones are most likely to successfully complete their um, their degree. Well, in that situation, you'd want to know what factors can I look at that will actually predict that, which factors actually correlate with you know being a successful student or completing your degree. So I'd want to know, what is the most predictive factor, or if there are there any predictive factors even. Is it high school grades? Is it the SAT? Is it some other thing? I don't know, but I'd want to know those because I want to be able to predict which high school students are most likely to succeed in college. Um, Another one is say something known as the GRE, the Graduate Record Exam, and graduate school. So when you apply to graduate school, you have to take the graduate record exam. It's kind of like an IQ test. It's they ask you all these questions, and you have to come up with these answers, and it's kind of meant to assess how well you'll do in graduate school. And it's not. I don't know what the correlation is, but I assume there's some correlation there between the graduate record exam and how well students do in graduate school. So I want to look at what were their scores on the GRE and how did they do in graduate school. However, that would be operationalized. How many publications did they get? How many? How was their teaching effectiveness? Did they finish grad school? Whatever it might be. Um, because just like with college, it's a very competitive process, and you have to consider which applicants are most likely to be successful. You want to consider, um, what factor does the GRE actually correlate with graduate school success? Because if it does, then we can again use that as a tool to assess who we're going to allow into graduate school and who we're not. So again, that's where prediction can be very useful, even though there's no actual causation necessarily. I mean, having high school grades doesn't cause you to be a better college student, but the studying and the hard work and being smart obviously does. But that's okay, right? Because we're mainly interested here in, does this factor predict this, because we want to be able to predict this. We want to be able to choose the best applicant. Um, One last example where correlational research can be very, useful might be applying for a job. So let's say if you apply to be a professor somewhere, well, you'd want to consider, what predicts. But that's an even more competitive process than graduate school. So you'd of course want to consider what factors are actually going to predict how successful someone will be as a professor, and that can help you determine who to hire. So is it, say, the number of publications they got as a graduate student? That's kind of the one to go with. Is it their teacher ratings? Is it their, you know, time they took to graduate? Whatever it might be. Again, you can use those factors to predict who's going to be who you should hire, right? So that's, again, just to recap, where correlation research can be useful. Sometimes prediction is what you want. Okay. Quick break there.